Hey guys, thanks for joining me. We are going to walk through a long Algebra 2 final exam review together as you guys are preparing to wrap up a semester of Algebra 2. And let's go ahead and get started. Let f of x equal 3x plus 7. Write a function g whose graph is a reflection in the y-axis of the graph of f. Whenever we have a reflection in the y-axis, that means that we are replacing f of x with negative x. So we're going to evaluate this function and simplify. So negative 3x plus 7, and that will be our g of x. So this is our answer. Number 2, your revenue in dollars for selling X hamburgers is given by f of x equals 5x, and your profit is $20 less than 70% of the revenue. What is your profit for 24 sales? So the first thing that we are going to do, I'm going to write this as a system of equations where we have y equals f of x, and then it says your profit, P, and it's $20 less than 70% of the revenue. Okay, so the revenue is going to be y here. So we have the profit is $20 less than 70% of the revenue. So we're going to do 0.7y minus 20. Okay. What is your profit for 24 sales? Well, we can go ahead and multiply or plug in x for 24 here. So y is 5 times 24, and that's going to be 120. Then we are going to go ahead and replace y with 120 here. So we have p equals 0.7 times 120 minus 20. So our profit is going to be 84 minus 20 is $64. Solve the inequality. If there is no solution, enter no solution. So whenever we have an inequality, I like to describe this as the distance away from the number or whatever is inside of the absolute value brackets here. So we're going to have the absolute value of 6, and the distance away from that is less than 0. Well, that doesn't really make sense here because what we would normally say is that the distance away is, let's say it's 3, then we would talk about the area in here, okay, from both sides. So this would actually be -3, this would be 3, and then basically the solution would end up within there. If the solution is less, if the absolute value, the distance away from x plus 6 is less than 0, there's going to be no solution here. Okay. Also, another way to think about this, when you take the absolute value of a number, there's no way that it can be negative. And that's what this means. So the answer is no solution. Number 4, write the equation in standard form of the function represented by the graph below. Well, we know that the parent function is a squared function, so we can go ahead and just plot the general points for that. Okay, and it's going to look something like this. So the transformation between the blue graph and the black graph, we know that it's reflected about the x-axis, okay, because it's down. So now our graph looks, or well, if we just do the transformation of the reflection, it's going to look something like this. Okay, and then if we go ahead and move it to the left, where if we just follow the vertex point and we say, let's go over 1, 2, 3, 4. We're going left 4 and down 1, 2, 3. So we're going left 4, down 3. And then that graph, okay, would look like this. Very close to what we have. The only difference between the graph that I just transformed of just the parent function and the black graph is that the black graph is a little bit skinnier. In fact, the points are stretched and multiplied by 2. So the way that I like to do this is going ahead and writing it in vertex form. I think it's a lot easier to do that. So the reflection, that's going to affect this negative here. The stretch by 2 is going to be this number here. And then we have a shift left 4. Now the standard function is going to be like this. Okay, just plugging it in. The negative is built into the formula, and then we're going down 3. So now we can go ahead, since the problem is asking us to write it in standard form, let's go ahead and simplify. And then we're going to go ahead and FOIL this. So we're going to have x squared plus 4x plus 4x plus 16 minus 3. Now we're going to distribute in this 2 to every term. Okay, we'll combine these when we do that. So we're going to have 2x squared, negative 2x squared. Okay, 4 plus 4 is 8 times negative 2 is negative 16x, and negative 2 times 16 is negative 32, and then we have minus 3. Now we can combine these. So our final answer in standard form is going to be negative 2x squared minus 16x minus 35. Write the equation in factored form of the function represented by the graph below. When it asks us to write it in factored form, what the easiest way to do is to look at the zeros of the function. So x equals 1, x equals 3. We can also see that it's a downward facing graph, which means that our a is going to be negative. Okay, now this function does not have any stretches or compressions, and the way that we know that is because we have our vertex here, we have 1, 1, and then from here down 2, down 4, let me see here. Sorry, from the vertex over 2, down 4. Okay, over 2, down 4, because our parent function looks like this. 0, 0, 1, negative 1, 2, 4, and negative 2, 4. Okay, so that's where I'm getting those points from. So there is no stretch or compression here. Now, if we're writing the factored form of the equation below, if we go ahead and subtract 1 from both sides, we'll get x minus 1 equals 0, and then x minus 3 equals 0. So we're working backwards from a regular equation. Now we can do y equals x minus 1 and x minus 3. And since we know that it is a downward facing parabola, we can include that negative out front, and this is going to be our final answer. Write an equation of the parabola in vertex form that passes through the point 1, negative 6 and has vertex 7, negative 3. So vertex form, as I mentioned before, looks like this. Okay, we are given the vertex, that's HK. We are also given a point, which will be XY. Here and here. So we have to solve for A. Now I'm going to color code this to make sure that you guys understand where I'm plugging these numbers into. So let's go ahead and evaluate this. We have negative 6 equals A times 1 minus 7 squared minus 3. Negative 6 equals A times negative 6 squared minus 3. Now we can go ahead and do the order of operations. Negative 6 squared is 36. We have that multiplied by A minus 3. Add 3 to both sides. So we get negative 3 equals 36A. Divide both sides by 36. So our A is negative 1 over 12 after simplifying. Now that we have our A value, we can go ahead and plug in the A with our vertex, and that's going to be our answer. So we have y equals negative 1/12 x minus 7 squared minus 3. What is the average rate of change of the function given over the interval between 0 and 4? In order to figure this out, we have to plug in these two values, get the corresponding y value, and then really just find the slope between the two. So let's plug in x equals 0 first. We're going to get y equals negative 5 ninths times 0 minus 2 times 0 plus 7. So y equals negative 5 over 9 times negative 2 times 7. So y equals negative 5 over 9 times negative 14. And that's going to be positive 70 over 9. Next, we have to do x equals 4. So if we plug in 4, we're going to get y equals negative 5 ninths times 4 minus 2 times 4 plus, times 4 plus 7. And then we have y equals negative 5 ninths times 2 times 11. So y equals negative 5 ninths times 22. And that result is negative 110 over 9. So now we can find the slope formula between these 2 points. That's going to be our y2 minus y1 over x2 minus x1. So we're going to have negative 110 over 9 minus 70 over 9 divided by the corresponding x value for negative 110 over 9 is 4, and the corresponding y value for, the corresponding x value for y equals 70 over 9 is going to be 0. So we're going to have negative 180 over 9 divided by 4. Negative 180 over 9 is just negative 20. So negative 20 over 4, and that's going to be negative 5. So that is the average rate of change between those 2 points. Solve the equation. So in order to undo x squared, we have to take the square root of both sides. The important thing to remember here is that whenever we take a square root, we also need to include our plus or minus. So this answer is going to be x equals plus or minus 3. Solve the equation and use a comma to separate your answers. So we have to go ahead and set this equal to 0. We're going to get x squared plus 5x plus 6 equals 0. And we're going to play the x game. We have to look at the number here and say what factors of 6 will also add to 5. So if we list out our factors of 6, we're going to get 1 and 6 and 2 and 3. So 2 and 3 are the right answers, and then we write our answers in factored form, and then we set both of these equal to 0. When we add 2 to both sides, we're going to get x equals 2. We add 3 to both sides, so x equals 3. When we write our final answer, this is what it will look like. Well, I just realized, okay, this needs to be a positive here, so these signs are all going to be flipped. Sorry. There we go. Number 10, solve the equation. We have the square root of negative 18. I like to go ahead and break this down into its prime factors. So 9 times 2 and 3 times 3. We have a pair of 3's, and those will come out of the radical. We also have a negative outside of our 18. And so we can remember that the square root of negative 1 is going to be a special number. It's going to be I. So if we have the square root of negative 1 times the square root of 18, this is going to be I, and this is going to be 3 radical 2. So our answer is 3I square root of 2. Find the product of -9 minus 5I times the quantity -9 minus 7I. Write the answer in standard form. We're just going to FOIL these. So we have -9 times -9, -9 times -7I, -5I times -9, and -5I times -7I. So that's going to be 81 plus 63I plus 45I plus 35I squared. I squared is -1, and that's going to be times 35. The combination of these two numbers added together is going to be 108I, and then we have 81. So if we look at the 81 and the -35, that answer is going to be 46, and then we have 108I. And this is your final answer. Number 12, write y equals x squared plus 14x plus 47 in vertex form, and then identify the vertex. Writing it in vertex form requires us to complete the square. So in order to complete the square, we are going to go ahead and write in a blank here. We're going to keep our 47 here, and then we're going to subtract the same blank. Basically, what's going to happen here is we are going to add a certain number inside this blank, but we also have to subtract it so that we're not changing the value of the equation. So what goes in the blank is b over 2 squared. Our b value is 14 in this case. We're going to take half of 14 and then square it. So 49 is going to go in both of our blanks. Now, it's important to note that it's called completing the square because every time that we do this, we are going to get a perfect square trinomial. That factors every single time to x plus whatever the square root is of this, x plus 7 squared. Then we have 47 minus 49, so this is going to be -2. This is the vertex form of our equation. And remember that our vertex is found by taking this value and this value. Since our vertex form looks like this, we do have to remember that we need to flip this sign in here. So our vertex is going to be -7, -2. Number 13, solve the system. We have a quadratic equation here and a linear equation. And what we can do is solve the second equation for y and then plug it into the first one. So let's add x to both sides. And we'll go ahead and get y equals x plus 15. So again, what we're going to do is take this value, plug it in right here, and then we'll be able to factor this equation. Now we are subtracting the whole quantity, and this is where a lot of students make mistakes. They often forget that we have to distribute this negative. So we're going to get 2x squared plus 25 minus x minus 15 equals -85. So we're going to get 2x squared plus 24x. And then we can go ahead and add over our 85 here. So this is going to be plus 70. Now we have to factor this. We have to do the AC method here. So 2 times 70 is going to be 140. We need factors of 140 that add to 24. The way that I like to do this is with a factor tree. And I always start with the numbers that got us that product: 2 and 70, 2 and 35, and 7 and 5. How we can find the possible factors is we can just list these out and then we group together certain types. So we already know that 2 times 70 is a factor. Now, if we group together these two and these two, that will be 2 times 2 is 4, and 7 times 5 is 35. If we group together these three, that's going to be 28, and this is going to be 5. Now, we also have, let's see here, right here. So 5 times 2 is 10, 7 times 2 is 14. And that's going to be the right combination of numbers to get us 24. So I like to use the bottoms up method where we're going to write these factors in our parentheses here. And then we look at our leading term here. Since we have a 2, we have to divide both of these terms by 2. So our answer is going to be x plus 5 and x plus 7. So we're going to get two solutions for x here. We're going to have x plus 5 equals 0, x plus 7 equals 0. So x equals negative 5 and x equals negative 7. In order to figure out what our corresponding y values are, we have to go back and plug them into either equation. I'm going to go ahead and plug them into the second equation because it seems a little bit easier. So negative times negative 5 plus y equals 15. So just to recap, I'm plugging it in right here. This is going to be 5 plus y equals 15. So y equals 10. So that point is going to be, running out of space here, but that one's going to be negative 5, 10. Then for our second one, we're going to have negative times negative 7 plus y equals 15. So 7 plus y equals 15, or y equals 8. So our second point is going to be negative 7, positive 8. These are the two solutions to the system of equations there. Solve the system using the graph. This is very simple. All we have to do is look at the intersection points of our two graphs. So this is going to be from the origin negative 5, 5, and also from the origin 1, 4. Number 15, write the inequality for the following graph. The vertex looks a little bit hard to see here, and it's in between a few numbers because these are all a scale of 1. So it doesn't seem like this will be easiest to write it in vertex form, but there are some other things that we can point out here. Our x-intercepts happen at perfect values, and so does our y-intercept here. So we can go ahead and write out our x-intercepts. That's going to be 1, 0, and 2, 0. In other words, x equals 1 and x equals 2. So if we subtract 1 from both sides, we're going to get x minus 1 equals 0 and x minus 2 equals 0. So I can write that next to each other here. We also know that the graph is downward facing, so we can include a negative on the outside. Let's go ahead and FOIL this. So we're going to get x squared minus 2x minus 1x plus 2 equals 0. So we're going to get negative x squared minus 3x plus 2 equals 0. Or negative x squared plus 3x minus 4 equals 0. And then let's look at our points here. But let's just back up one step right here. So negative a. Okay. So what we're going to do here, I'm just going to erase this last part. And I'm going to set this equal to y instead of 0. And I'll explain to you why I'm doing this. We need to figure out the stretch or compression here. And we also have this other point that we've not used yet, 0, negative 4. So what I'm going to do is I'm going to plug in 0 for x and then negative 4 for y. And then we're going to find out our y value there. So if I get 0 squared minus 3 times 0 plus 2 equals negative 4. So inside of my parentheses, I'm just going to get a 2, and then I'm going to get negative 4. So you can see here that a is going to equal 2. Now that we have solved for a, we can go ahead and distribute that in. So this is going to be negative 2 times the quantity x squared minus 3x plus 2. So our final answer is going to be negative 2x squared plus 6x minus 4 equals 1. So I want to show you guys this trick that has been a game changer for me in order to figure out inequalities. So what I do for my inequalities is I go ahead and cover up most of my equation except for the constant value. And I look at this and I say, okay, if I were to isolate our y-axis here, the way that I like to view this is looking at our graph at negative 4 and seeing which direction is shaded. Are these values greater than or less than negative 4? They're going to be greater than. So that means y is greater than or equal to, okay, remember, I know the symbol looks like it's less than, but we're eating the larger number. The alligator is eating the larger variable or the larger number. So y is greater than. Okay, so what our equation actually looks like, y is greater than or equal to negative 2x squared plus 6x minus 4. Now this is our final answer. Number 16, find negative x cubed plus 2x minus 2 divided by x plus 4. I'm going to choose to use synthetic division here. And in order to figure out what goes in the box, we're going to set the denominator equal to 0. So negative 4 is what goes in the box. And then I'm going to take my coefficients. So negative 1, 2, and negative 2. You might be wondering why I left out a big space here. That's going to be for my x squared term that we don't have. We do have to make sure that we have every single degree from the leading coefficient all the way down to the constant number. Now, in order to perform synthetic division, we're going to go ahead and bring down our first number. Now we're going to multiply these two values and write the result here. Now we add straight down and repeat the process. Multiply these two values and put the result here. Add straight down. Now we multiply these two values, put the result here, and add straight down. So our answer is going to be negative x squared plus 4x minus 14 with a remainder of 62. And depending on how your teacher wants you to write it, you could also write it like this, plus 62 over the original divisor. My remainder, that's what I get for trying to do mental math here, should be 56. So this is going to be 54. And all that does is change this over here. Number 17, factor x cubed minus 8y cubed completely. This is a difference of cubes, and so there is a formula that is associated with this. Okay, a difference of cubes is a cubed minus b cubed, and that's going to be a minus b times a squared plus 2ab plus b squared. And in order to figure out what goes in the position of a and b, we have to set our terms that were given equal to a cubed and b cubed. So I'm going to show you how to do that. If a cubed is x cubed, we can take the cube root of both sides. So a is just x. We're just going to replace every single a that we have with an x. Now we have b cubed equals 8y cubed. So we're going to take the cube root of both sides. The cube root of 8 is 2, and the cube root of y cubed is just y. So we are going to replace every b with 8y. So let's go ahead and write this out. We're going to have x minus 8y. Cube root of 8 is 2. Now we are going to have x squared plus 2 times x times 2y plus 2y squared. So we have x minus 2y, x squared plus 4xy plus 4y squared. And this is factoring completely. This is just applying a formula. We don't really have any other ways to factor this. So this is your final answer. Here is a cubic polynomial, number 18, factor x cubed minus 5x squared minus 16x plus 80 completely. We're going to apply factoring by grouping here. So we're going to group together the first two terms and the last two terms, and we're going to look to see what they have in common. Now, some students struggle here, so I'm going to write this out this time. I'm not going to write this out every time, but I want to show you guys how to figure out what the GCF is. So negative 16, if we break down negative 16, we have 4 and 2, 2 and 2. Excuse me, 4 and 4, which is 2 and 2, 2 and 2. So this is going to be negative 2, 4 times x. And then we have our 80 that we can also break down into 40 and 2, 2 and 20, 2 and 10, and 2 and 5. So we're going to have 4 2's times 5. Okay. The way that we see what to take out is by going through and seeing what each of them have in common. So the first two terms have an x squared in common, and what's left is an x minus 5, these two terms. Now, in order to see what the next two have in common, we can see that it's 2 times 2 times 2 times 2, which is going to be 16. But we're going to take out a negative 16, and I'll show you why. So we're going to have an x, and then if we pull out a negative, we'll have minus 5. So when you do this, these two factors should match all the time. And out of these two terms, we can go ahead and factor out an x minus 5. So what's left is an x squared minus 16. You may recognize this, but this is called a difference of squares. So it actually further factors. The difference of squares formula says if we have a squared minus b squared, then it's automatically going to factor to a plus b, a minus b. So basically, essentially, you take the square root of both of these terms and then fill it in down here. So our final answer for this is going to be x minus 5, x plus 4, and x minus 4. Determine whether the function is even, odd, or neither. So in order to figure this out, we can look at the coefficient and the exponent, and we can see that this exponent is odd. Okay, so our answer is actually going to be B. But if you wanted to algebraically figure this out, an odd function says that when we plug in negative x for x, that we get the negative version of our function back. So since we have the equation there, if we plug in negative x, everywhere that there's an x, you will see here that we're going to have negative x to the fifth minus 2x, which is exactly the negative version of our original function. So it's odd. Number 21, simplify the expression 32 to the negative 2/5 power. So when we look at a negative rational number in the exponent, the negative is going to make our base go to the denominator. So this is going to become 1 over 32 to the positive 2/5 power. This number here is going to become the index of our radical, and this is going to be the exponent. So this is going to become the fifth root of 32 squared. Now the fifth root of 32 is 2. If you didn't know that, what we could do is break this down into the prime factors. And we're looking for a group of 5 similar numbers in order for it to come out of the radical. We have 5 2's, and so that's how I knew that. So our answer is 1/4 here. Simplify the expression, the fifth root of 64. We know that 64 is 8 and 8. And we know that 8 breaks down into 4 and 2. And that 4 breaks down into 2 and 2. So from here, what we're looking for are groups of 5 numbers. And we have a total of, let's see here, 5 2's right there. Okay, so this is going to be one group of 2's. And then we have an outstanding 2 that's left. So this is going to be 2 times the fifth root of 2. Write an equation for the following graph. So the parent function of this is the square root graph. We can know that by the shape of the graph. Now, the square root graph goes from 0, 0, 1, 1, 4, 2, because the square root of 4 is 2. The square root of 9 is 3. And then this is what our graph looks like. Okay, so it is definitely smushed down a bit. So we're going to have y equals a square root of x minus h plus k. You'll notice that the transformations pretty much look the same. On our transformed graph, we can see that we have some different points here. We have 2, 1. We also have 8, 2. So we can go ahead and plug in these points and then solve for a. Okay, so we're going to start with 1 equals a times the square root of 2. And h and k, there are no horizontal or vertical transformations. You can tell that by the vertex here. That point does not move between our graphs, so there is no transformation. In order to solve for a, all we would have to do is take the square root of 2 and divide it on both sides. So now we can rationalize this because we can't have a denominator on the left side, or excuse me, a radical in the denominator. So this is going to be the square root of 2 over the square root of 4, which is the same thing as the square root of 2 over 2. So from here, we have y equals the square root of 2 over 2 times the square root of x. So in other words, y equals the square root of 2x over 2. Number 24, solve x plus 9 equals the square root of 2x plus 21. The radical is already isolated, which was a great first step. So we're going to square both sides. And remember that the exponent on a binomial is the amount of times that the parentheses are repeated. You are never going to distribute an exponent across a binomial. Once again, it's the amount of times that the parentheses are repeated. Now that we squared the radical on the right side, it's going to free up what's underneath of it. We're going to FOIL the left side here. Now we are going to combine like terms. So we can subtract 2x from 18x. And while we're at it, we can go ahead and subtract 21 as well. So we're going to get x squared plus 16x plus 60 equals 0. Now we can factor this by playing the x game. We're looking for factors of 60 that add to 16. So it's going to be 10 and 6. Now we can go ahead and set both of our factors equal to 0 and solve for x. Now it's very important here that we have to go back and plug in our answers back into our original equation to make sure that we don't have any extraneous solutions. So let's check x equals negative 10. We have negative 10 plus 9, and we're checking if that equals the square root of 2 times negative 10 plus 21. So we have negative 1. Does that equal the square root of negative 20 plus 21? Does negative 1 equal the square root of 1? The answer is no. So x cannot equal negative 10. Let's go ahead and check negative 6. So we have negative 6 plus 9. We are checking to see if that equals the square root of 2 times negative 6 plus 21. So we have 3. We're checking to see if that equals the square root of negative 12 plus 21. 3 does equal the square root of 9. So our answer is negative 6 here. Let f of x equals 2x and g of x equal x to the 1/4. Find f times g of x. This problem is just asking us to multiply these functions together. So we have 2x times x to the 1/4. When we have two bases that are the same, we can go ahead and add their exponents. When an exponent is not written, it's really a 1. And so we're going to get 2 times x to the 1 plus 1/4. Now, standard rules apply here. When we are adding fractions, we do have to get a common denominator. So we have 2x to the 4 over 4 plus 1 over 4, which is going to be 2x to the 5/4 power. Number 26, let f of x equal 2x to the negative 1 and g of x equal 6x minus 6. Find f of g of x. I like to think of these problems like Russian nesting dolls, where we're starting with g of x on the inside and we are plugging that into the other function for x. So again, we are going to replace wherever x is in the function of x with our g of x function. So this is going to be 2 times 6x minus 6 to the negative 1 power. Remember that when we have a negative exponent, it's going to put that base in the denominator. So we're going to have 2 over 6x minus 6, and then we can go ahead and reduce that to 3x minus 3. The graph of a cube root function 2 times the cube root of x is shown. The graph of g is a vertical shrink by a factor of half of the graph of f. Write the equation for the function g. Since the function that we are given is 2 cube root of x, and we are having a graph that is a vertical shrink by a factor of a half, all that we're going to do is we are going to multiply this by a half, which means that our 2 and our 1/2 are going to cancel, so we just end up with the cube root of x. Number 28. Tell whether the function f of x equals negative 4x plus squared plus 9 is invertible. Well, in order to figure this out, all we have to do is put in our y equals negative 4x squared plus 9, switch x and y, and then solve the equation again for y. So we'll subtract 9 from both sides. We'll divide by negative 4, and then we'll take the square root. So here we go. Now, the problem with this is that we have a negative under here that is going to cause an issue with taking the square root. We will end up with an imaginary number. So in this case, our function is not invertible. Determine whether y equals e to the 0.5x represents exponential growth or exponential decay. You may recall that e is just a number. It's approximately 2.7. Since the base is greater than 1, it's going to be exponential growth. Number 30, describe the transformation of f of x equals log base 2 of x, represented by g of x equals negative log base 2x plus 2. The same transformation rules apply here. Since we have a negative out front, it's going to be a reflection in the x-axis, and then we have a vertical shift up 2. So our answer is C. Number 31. In 2013, the population of a city was about 234,000. During the next 7 years, the population increased by about 4% each year. Write an exponential model that represents the population y of the city T years after 2013, then estimate the population in 2020. So let's talk about what an exponential function looks like from inception. So we are going to have y equals a times 1 plus the rate raised to the t value. Now, the first initial population is going to be this value here. Some textbooks use different variables. I'm just using a here. Now we have during the next 7 years, the population increased by about 4%. So we need to turn that into a decimal, which is going to be 0.04. T is going to be 7. So now once we evaluate this, we will figure out what um, the population will be in 2020. So I'm going to plug this into the calculator. So the equation is going to be y equals 234,000 times 1.04 to the t power. When t is 7, our estimated population is going to be 307,928. Number 32, find the inverse of f of x equals e to the 4x. So we're going to have y equals e to the 4x or x equals e to the 4y now that we're trying to find the inverse. Now we need to take the natural log of both sides since we are trying to get our exponent down. When we do that, the right side will cancel out, so we'll have the natural log of x equals 4y. Now we will divide both sides by 4. to get the natural log of x over 4 equals y. And then we have to change our y back into the inverse to make sure that we get full credit on that. Number 33, write the rational function shown in the graph below. So I'm going to make a couple observations here. One of them is that we do have a vertical asymptote, and you can see that the arrows are going very close to x equals 2 here. Another observation is that it looks like we have a slant asymptote as well, and it kind of looks like we are going this way. Okay, it's approaching, might be a little bit off, but anyway, it looks like that's going to be our slant asymptote there. Also, again, just making some observations here. We do have a y-intercept at 0, 4. We have an x-intercept at -2, 0. Another x-intercept at 4, 0. And if we need another point, looks like 6, 4 would work for that as well. Okay, so whenever we have a vertical asymptote, we are going to have x equals 2, and that is our VA, which is found in the denominator. Okay, so if we subtract 2, that's going to mean x minus 2 is going to be the factor that we are going to see in our denominator. Now, because we found the zeros of the function at -2 and 4, we can just go ahead and write down that x equals -2 and x equals 4. So x plus 2 and x minus 4 are going to be the top. So we can go ahead and write this function as x plus 2, x minus 4 over x minus 2. If we want to go ahead and write that, just distribute this out. Okay, this is our final answer here. Okay, we know that there is a slant asymptote because the degree is exactly 1 degree higher in the numerator than the denominator. And if we were to go ahead and do polynomial long division, we would find out what that slant asymptote, the exact equation of our slant asymptote is. Number 34, simplify the rational expression x squared plus 9x plus 18 divided by x squared plus minus 9. We can go ahead and factor the numerator and the denominator. The numerator is going to factor to x plus 3, x plus 6, and the denominator is going to factor to x plus 3, x minus 3. Here we're going to have a whole at -3, and so simplifying the rational expression, this is going to be x plus 6 over x minus 3. Now we also know that our denominator is not allowed to be 0, so x is not allowed to be 3. Number 35, find the sum of 7 over 3x squared plus x over x squared minus 2. So I'm going to show you guys a really cool way to solve this that works every time. So we're going to multiply the bottom right side to the top left side. We're going to multiply the bottom left to the top right, and then we're going to multiply the denominators. So 7 times x squared minus 2 plus x times 3x squared over 3x squared times 3x times x squared minus 2. After we distribute this, we're going to get 7x squared minus 14 plus 3x cubed over, we can leave our denominator factored. So this is going to be 3x cubed plus 7x squared minus 14 over 3x squared times x squared minus 2. Number 36. An alloy is composed of 75% copper and 25% zinc by weight. You have 27 ounces of copper, so how many ounces of zinc do you need to make the alloy? The way that I view this is that 25% is a third of 75. So if we have 27 ounces of copper, a third of that is going to be 9 ounces. Number 37, the function c of x equals 10x plus 500 over x represents the average cost in dollars of making x items. How many items must be made for the average cost to fall to $30? So we're going to replace c of x with 30 and then solve the equation. So once we replace that, we're going to go ahead and multiply over this x to get 30x equals 10x plus 500. Then we can subtract 10x from both sides. So 20x equals 500. Now we can divide both sides by 20. So x is 25. So if you've made it all the way through with us, thank you so much for joining us. Make sure that you subscribe to our channel to make sure that you can ace your next test. If there's anything that you'd like me to cover, I would be more than happy to consider doing that. Just go ahead and comment below. I hope this was helpful, and I hope you have a great day.